Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So we are from Group 10. So my name Muhammad Haikal Aziz bin Muhammad Azli.
My name is Muhammad Syami bin Nizam.
And my name is Muhammad Abbas bin Muhammad Ismail.
So this is from our equation. So maybe in bracket a plus b power of 2. So we divide it with in bracket c minus d with the power of e to close the bracket. So we direct for our coding by using Little Mac Computer. So this is our coding. So at the first, we put our input is A, and then we store at the address 80, and then for the next input, we put B, and then it will directly take from the register 80, put inside accumulator and do the arithmetic, which is additional, and it the output will come out after the process, and then after the additional, it will store back at address 80. So as you can see from here, Little Me Computer. So this is our output, and then the output we will be stored back at 80. So that's for additional process.
Alright, for the power of 2 process, as you can see here, the equation between A plus B is 25. So the power of 2, so we can do the power of 2 directly in the Little My Computer, nor the multiplying. So we need to do the other method, which is one of it is we add on. So basically we add on the same number. 25 plus 25 is equal to like 50. It's basically the same as the power of 2. So what we do, firstly we sub y at the address 66, and then we store the number n at address 64, and then we add on the number of that we need, which is 25, and then we store the number at address 65 and load A in 65, and then we store the number at 80, and then the first thing is we do is LDAN, which is store at 64, and then the BRZ, basically the address in 21. After that we do the LDAA, which is address is 65, and we add 80 at 80 and at address 80. So we store the number at 65, and then we LDAN at 64, and then we sub at 66, which means sub at accumulator, and then we store it at 64, and then BRA at address 12, and then lastly we LDA at 65, and then we will get the result for the power of 2, as you can see here. Alright. Oh, my bad. It's not 50. Basically, it's like a repetition to get still 635. My bad. Alright. I will give to Shahmi to.
And not me.
Not you yet. Oh, okay, I'm sorry. So I will give it to Haikazi to proceed with the equation.
Okay, thank you, Muhammad Abbas, for the power of two explanation. So after we execute the power of two, we go to the next process, which is the sub. So sub is very straightforward, like a plus. So basically, we assume our input
Hmm.
as 18, and then it will go store at 81, and then we will assume for the input as 13, and then it will straightforward, the input will be stored at 82, and then after that it is load inside 81, and then the next process, it will take the data from the register 81, do the sub arithmetic at arithmetic unit, and then the output we will come out, and then it will restore back at the address 82. As you can see here, the answer for our sub will be 5. So we continue for the next.
So I will explain for our multiplication operation. So first, this is we subject our subject with z is uh, us at the 69 address, and we store SDAO, and that one we store at 67. So we, and then next step we put the input, which is E, and STAB, for our B it will uh, store at 68, and load 60 B 68, and then we store at address 81. So here load O, which is our O is 67, and BRZN, which is when the value of O is 0, it will do the will end the process, and then LDAB, which is our B is 67 and 68, and at 81 store B, load O, subject, and then SDAO, BRA loop. So here when the value not 0, we will loop here. We loop here and do other operation. And then after get the 0 equal, the output 0, the O value is 0, we'll end here and look at B. And and we'll go to output and store the output will store at 91. So I will run here. So I will go fast. So here I will put value E, which is 5. So the input will go to the accumulator, and we'll do the operation. So as you can see, for the at here 381, which is this 3 is, it means instruction register. The 3 is means store. So 81 is address register. So 81 will is this mean it store the value that will store at the 81 81 address. Address 81. Yeah. So 5 is load. So the 67 will take the value from 67, we put the accumulator. So I will go fast. Here you can see it's already looped. So I will directly to the our divide. So our divide is from here. From here, load LDA 99. We take from value from sorry, LDA 99 is mean we will reset the value. We reset the accumulator first, and we store the value from address 92, which is the after the value of the C minus D times VE. So we load the 90, we will load the 90 value, so which is here, and then it's same like the multiplication process. We will loop same, and then our output will go to 92. So I will go fast. Yeah, so as you can see, this 25 is our value or add operation. This one is power of 2. This one is after we, this one is value of, sorry. 25 is value, okay. So this is the final answer. So 25 is mean A plus B, and then this one is A plus B power of 2. This one is C minus with D. So 25 is power, sorry, 25 is C minus D times VE. So here is our final operation divide. So that's all from me. Thank you.